So we're here to tell you how to get more out of Maven. My name is Marit van Dijk.
And Anders Almiray.
Here's a list of some of the things that we want to talk to you about, but we'll go over them one by one. First, getting started. When you create a new project from scratch, you can obviously create a Maven project. So in IntelliJ IDEA, when you create a new project, if you're zoomed in, then the pop-up doesn't scale well. So when you create a new Java or Kotlin project, you can select Maven. If you create
it's not being it's still not being mirrored. I'm sorry about that, because we're actually looking at pretty nice slides on this side.
Yes. Yes. Where is my
really nice color? So this is probably the other desktop.
Yeah.
Could be like the case.
How?
And he went over here and yes, exactly. And over there.
Change. Extend display.
That's the one in the middle, that one?
Extend display. No.
No, or maybe we have to move the window to the other side. It's an interesting setup, actually. First time that something like this has happened to us, because we can see the presentation here on the screen, but not on the mirror side.
Yes. I don't know.
No, not this one.
Here, and the IDE is here.
So we'll be switching between desktops.
Yeah, we'll be switching between slides and IDE.
Okay, we got something.
Oh.
That screen's mounted.
Okay, but if I switch?
Yes.
Yes.
Perfect.
Woohoo! Perfect.
Yay! Welcome to the TED Talk.
So, Marit, Andres, agenda, new project.
You will get a QR code with the slides and the code that will see. So don't worry, everything will make sense.
Yes. At the end, I'll provide the QR code. So when you create a new project in IntelliJ IDEA, if you start a Java or Kotlin project, you can start your Maven project. If you start a Spring Boot project or a Quarkus project, those connect to the Spring Boot starter or the Quarkus equivalent. So it will take the default from those, from start.spring.io, which is Gradle Groovy, but you can change it to Maven if you want to. And you can also use Maven archetypes, which are kind of templates for your projects, and you can manage catalogs if you have your own catalog of Maven archetypes, and select an archetype and provide additional properties that you might need for your archetype. I will not create a new project. I have too many demo projects already. So we've just shown you this. But you might want to use the Maven wrapper.
Does anyone here doesn't know what the Maven wrapper is? Okay, so most of you know what the Maven wrapper is? Yeah?
Is everyone using the Maven wrapper?
Okay, just half of, so you know, but half of you are using the wrapper. Okay.
Interesting.
Good. Yes.
So the upside of using the wrapper is that your project will always build with the same version, which will make it more reproducible and reduce build variance. Let's go to our demo and actually add the wrapper. We'll use the latest Maven version.
Released 1 week ago.
Exactly. And hope that my connection holds. Yes, it did. Okay, so that adds the wrapper to our project, as we can see in the commit tool window.
Right.
I'm going to keep going the wrong side because normally my slides and IDE are the other way around. So that brings us to the very important question. How do you build a project?
Which command do you use to build a Maven project? Yes, Maven clean install. The door is over there, please. No, I'm joking.
We want them to stay because they might need to learn something.
Yes. Any other way that you will run or you build a Maven project? Native compile? Yes. Another one? Package? Yes. Possibility? Another one? Okay, this is why you're here. Good. Because there is a better way to build Maven projects. It's called Maven Verify. Maven Verify is one of the many lifecycle phases that you can invoke, such as clean, install, package, test, compile, process resources.
Exactly. And if you do install, that actually installs it in your on Mac.m2 folder, which means that that's going to grow. As we will see when we explain the life cycles and goals, Verify does everything except for install. So
basically, Maven is an execution engine that takes a set of lifecycle phases that go in one order. The most typical order is when you say something like compile or install or verify. Then the first thing that happens is it initializes the whole thing. No, I think the first one is validate, that checks that the XML that you've written in the POM XML is valid. Then initializes all the plugins, then goes into the next step will be generating the resources, compiling, testing, packaging, verification, and install. And sometimes you will see deploy, right? So it goes in one direction. And for each one of these lifecycle phases, plugin goals will trigger. And a plugin goal could be something like the compiler compile goal, or it could be the generate resources goal from the resources plugin, and so on and so on. So you think that phases could move in one direction, whereas the goals move in the other direction.
Right. And so if you use a phase like verify, it does everything up to verify. So if you do install, it does verify as well, but then plus the install. So unless you actually need to install it, you don't have to call install. Maven verify is enough.
Right, because you can see here that every time you're invoking explicitly install, the verify goal is invoked for you because it's part of the sequence. So you don't have to do install all the time. Verify for most of the times should be fine.
Exactly. So how do we run these goals? We can run them from the terminal, obviously, and from the IDE. So we can use Maven verify from the command line. And why do we have a build failure? There's no POM in this. Oh, and because I'm in the wrong directory.
In the wrong directory, yes. Now we're in the project directory, and then we can say again Maven verify.
Yes. And we have build success. So that, and here we see that it's actually going through the phases. So compile, test resources, test, compile, test. Right. But of course we added a wrapper. So really we want to run mvn-w verify so that we use.
I will probably add the wrapper in the directory upstairs. To add the wrapper again.
Yes. We added the wrapper in the directory. Yeah. That monitor thing threw me. Okay.
So one more time, invoking now verify through the Maven wrapper.
And then it uses the version that we installed with the wrapper, which is 3914, the latest version.
Yeah. But we can also run the different Maven goals through the Maven tool window, which is directly inside the IDE.
Exactly. So then if we go to our simple demo in the lifecycle, we see all of the default lifecycle phases. If we want to show all of them, so remember from the diagram, somewhere a lighter gray and somewhere a darker gray, we can uncheck this option to see all of them. But normally the basic phases should be enough, and we can click them to run them. Or we can modify our or run configuration if we want to add Maven options or Java JVM options. And we can store it as a project file if we want to keep this run configuration. So if we have a lot of configuration in our run configuration and we want to save it, we can do that.
Yeah, so it saves you time. Instead of typing all the time in the terminal, all the different options, just save it as a run configuration and then invoke it one click.
Yep. And another way to run commands is by using run anything, which is on Mac control. And then if you type MVN, it will find all of the relevant Maven commands for your project, which includes the phases, plugin goals, and any flags that you might want to set. So you can run that from here as well. And it will remember the run configurations that you've ran recently. So we've shown you these, but we added them to the slides for you to see if you want to review. So Maven comes bundled with IntelliJ IDEA. Currently, the default bundled version is 3.9.11, and you can use the bundled version, the wrapper, or point to an installed version, for example, if you want to try out Maven 4 already. So if you go to the settings, you can see which version is bundled. I'm on the latest release version, which is 25, I can't modal dialog, 2025.3.4, I think. So here we can go to the wrapper if we want, or if we want to, for example, try out Maven 4 already. I'm using my sound cut.
Okay.
Okay, interesting. So I'm using SDKman to manage Java and Maven. So I downloaded Maven 4 latest release candidate, which is RC5, and I could point to that if I want to try out Maven 4 already, but I won't for this demo.
On a minor detail, anyone here using SDKman to keep your installations on Maven up to date? A few hands.
Please thank Andres for keeping the versions in SDKman, the Maven versions.
We cannot recommend enough the use of SDKman to install a Maven, Gradle, any other Java tools. Well, Gradle is a thing, right?
JDKs.
JDKs from different Java vendors. So if you haven't had a look before to SDKman, go to sdkman.io. You won't be disappointed.
Yep.
Except if you're using Windows, because SDKman is written in Bash and is currently being ported to Rust natively, so they will work better on Windows. So just watch out.
They're rewriting to Rust.
They're writing Rust. It was written in Bash, so it's okay.
Okay. Thanks. Anyway, so we've showed you this. Hopefully convinced you to use Maven Verify instead of Maven Clean Install, unless you actually need to install something. So please use Maven Verify to make Andres happy, or better yet, use the wrapper to make our Polish friend happy. So Alina takes a picture to snitch tag. Next, let's talk about inheritance.
Because it's easy to talk about a single project. Most of the things that you would do with just one single POM file should be quite straightforward, but the moment that we start to add more modules or sub-modules, then things will start to get complicated, especially when you want to have some common configuration or properties defined in a particular place that can be inherited or passed on to other sub-modules. And then you figure out that sub-module is having a value that is coming from some random place that we don't understand, and it's not the right value that we want, and then things start to just go crazy, right? So the whole point of this is that we have to know, we have to understand or remember that Maven works in a hierarchical way. You write a POM file, which can define or declare that it can have another POM as a parent. But this other POM could have another parent explicitly, and on until you reach a POM that does not have an explicit parent section. But yet, this POM, like anyone else, could have, or actually has, something that is called the super POM. This is the root of the whole Maven hierarchy. And this is the POM that defines the basic or the defaults for building a Java project. Because if you do not define the version number of a plugin, such as compiler, resource, jar, sourcefile, all this, these values are coming from somewhere, right? That somewhere is the super POM. And these values, the super POM, this configuration is tied to a specific version of Maven. So if you run Maven 3.8.9, the plugin versions could be some numbers. But if you run Maven 3.9.14, the latest, the plugin versions will be different. And if you run Maven 4, plugin versions again will be different. So if just by switching Maven version, your build will not be reproducible and will have some variance. One of the reasons why the Maven wrapper exists. If you do not fix all the plugin versions, then you can rely on the wrapper saying, I want this version of Maven to be used so that you know this version of the superpon is being called. Now, that's the reason why I mentioned the Maven wrapper there. If you are confused of from where information is coming, then we can always invoke the effective pump goal to generate the full resolve model of a particular project.
And that's so you know what Maven actually resolved, so what you're actually using.
Yes. So even though what you write in your pump file may be short, of course, Maven knows much more about your project. So if we go now to the demo and run we do Maven verify on this inheritance project, we'll see we have a bunch of submodules with some dependencies one to another, and project 3 has configured the exec plugin so that we can run a main class. So if we run Maven verify through the whole project, we will see everything just being executed.
Okay, let me switch to the right project. So we do Maven verify.
And we use the wrapper.
And we use the wrapper.
And you see there's a bunch of information coming out on the terminal. And at the end, we have a summary of all the different projects that were executed. So there's a whole set of projects that we have in this multi-project setup. And if we continue scrolling a little bit upwards, there will be some printout, something like 1, 2, 3. I think that is the printout of the main class somewhere in project 3. I think we're already we're all the way to the top. So now we keep scrolling down maybe a little bit when we see project 3. That's project 4. It's somewhere in the middle. Somewhere like this, sorry. This should be project 3. Here we go. We don't see anything because we didn't invoke the exec goal. Right.
Right.
We just did verify.
Yes.
Okay.
So we run this and then we
should get now the printout of project 3. There's a lot of goals that are now being invoked, and there is somewhere 1, 2, 3 that appear a little bit down. And here we go. There's a 1, 2, 3 over there. That's project 3,
right,
based on all the configuration. But if we are unsure of how things are going on, now we can invoke the help effective pump goal.
Yep.
And this will do it for all of the projects in our reactor. I believe that's the case. And then we'll see that there's a bunch of XML coming out. And when we pass this verbose option also on the command line, we can ask Maven to tell us where that line was resolved from. So if it's coming from our pump file, from a parent, or from a super pump. So you see on the cyan color on the right side of the screen, that's where that particular setting is coming from.
Right. So from Maven core, or the super pom is in there somewhere.
There we go.
So you can see where everything is coming from and how it's resolved. So
at any point in time, whenever you find that you don't understand why Maven is doing something, just create the effective pump, and then this is exactly what Maven knows about your projects.
Yep. So profiles.
Anyone here uses profiles? Okay, almost half of you. Pretty good. So profiles is a way for you to conditionally change the behavior of your build. The most typical case that I would say is if you want to configure plugins that perform quality checks that take some time, or generating the Java doc that takes some time. For those of us that are open source developers and push out to Maven Central, we have to follow certain rules. And one of those are that we have to create a Java doc jar and a sources jar. It makes no sense to create those jars every time that you're doing Maven verify, right? Don't do clean install. So we should put the definition of those plugins into a profile so we can conditionally enable or disable the invocation of these plugins.
Great. So let me change to the other demo.
And in this demo, we have something that is quite basic if we look at the POM file.
Yeah.
And we have a set, we have, I think, just one profile that says publication. And what we did in this profile was put the Java doc and the sources jar in a separate profile. There are many ways that you can activate a profile, whether it's a JDK is available, or a file, or a property. In this case, we're going to also activate the profile by explicitly saying, I want to use the given profile ID in the command line.
Right. So first, if we build it without the profile,
and you see the build, perform package, and if we look into the target directory, there should be just one jar, the production jar.
Yep. But if we run it with the profile, which tells it to generate the Java doc and
the sources jar.
Thank you. Then we see that those are created as well.
Right. So if at some point you have had issues with your builds being slow, perhaps it could be because your build is performing additional tasks that should be happening at that point in time. So you could move those tasks into profiles and activate them whenever that's needed.
And then we have the enforcer plugin, because we want our builds to be reproducible and to maybe verify that we're using the right version of Java or Maven or anything else that we want to check and maybe restrict. So we want to have some checks on dependencies, make sure that we don't have duplicates, and more. And for that, we can use the enforcer plugin, which we can configure like so. And the enforcer plugin is also called the loving iron fist of Maven, which sounds slightly ominous, to be honest. But you know, it will give us a way to configure the rules and make sure that our project fails if it doesn't meet those restrictions.
Who uses already the enforcer plugin? Okay, almost half of you. That's good.
Oh.
If there's, of course, we want you to take home many things, but if there were to be only one, is
Enforcer plugin.
Enforcer plugin. Yes.
Yes. And we can add extra rules using the extra enforcer rules, like enforcing bytecode version, etc., which we can also configure. But let's go to the demo first.
Yeah.
And let me switch to the right demo, close these.
So we have a project where we want to ensure that we have we're verifying the given project invariance, like what is the given version of Maven and Java that we need to build this. Because oftentimes, if someone documents on the project, you need Java 25, or actually Java 26 should be now the norm because it just came out last week. But if it's documented but it's not enforced by the build, then the build might break or not, or you have to go into a wiki page somewhere in the enterprise to figure out how to build the project. But the enforcer can tell you things right away directly in the project.
Yes, and so in this case, we've defined that we want to run with Java 21 and Maven 399, but I'm actually using SDKman, an SDKman RC file to set the Java to a 17 and Maven to an older version. And I've configured my SDKman to automatically apply this. So that's why you see that we're now using Java 17 and Maven 389 in this shell, so that when we run this project with the Enforcer plugin, we expect it to fail, which it obligingly does. So
this actually the compiler plugin failing. Maven Enforcer plugin is failing, yes?
Yes, which is what we expected, yes, because it enforces that we use Java 21, but we're currently using Java 17 on the command line, which we already saw. But here we see that we're using Java 17. So if we switch our Java version to 21 and our Maven version to the latest, and apply that. Now we're using 21 and the latest Maven. So now if we build our project, it should not fail. and we have build success. So Maven Enforcer plugin can make sure that you're building for the right Java versions, etc., etc.
Yes. So Enforcer paired with the wrapper allows you to bootstrap a particular version of Maven, but also check that if for whatever reason someone is using an external version of Maven that is not the wrapper, then the project will either succeed because it's the right version, it's a matching version, or it fails because it is not the right version.
Exactly. So going back, so when you enable the Enforcer plugin, it might break your build. That's actually intentional. It shows you where your build is not meeting your current expectations or constraints. But if you're building your project without the Enforcer plugin, you're not meeting those constraints, but you don't know that you're not meeting them. So use the Enforcer plugin.
It is very likely that if you're not using the Enforcer plugin, your builds are broken in one way or another. But the Enforcer plugin, once those rules have been configured, will bubble up all those things and show you whether with warnings and errors that there is a misconfiguration in the properties, or there's an issue with dependency convergence, or there's something else. There's maybe a file that is missing at some appropriate time. So really, we cannot stress enough, have a look at the Enforcer plugin, and that will actually make your builds much better.
Yep. And then we go to dependency and plugin management. Obviously, we're all using lots of dependencies. Who had fun with Log4 Shell and such?
Yay!
Fun?
December 2021 was fun, right? Lots of presents.
Fun. So we know that we have to manage our dependencies, keep them up to date. Hopefully not add too many, because all of them you have to keep up to date. But when adding dependencies, let me switch to the right project then as well. So if we are adding dependencies, IntelliJ IDEA has code completion in our POM file. So for example, if we want to add JUnit, it will get the versions from your local cache. So it doesn't currently have all of the versions that are available on Maven Central, but we are working on a feature which will hopefully drop in not the upcoming major release, but the next major release, where we will have completion for versions that are available on Maven Central. But currently it gets them from your local cache. So if you don't have it in your local cache, the version number might be shown in red until you sync your Maven project. But I just wanted to show you that you have this code completion here. And also that you can see your dependencies in the Maven tool window. So here you can have a look at your dependencies and expand or collapse as needed. Obviously, this is a very tiny demo project. Your own projects probably have way more dependencies. But there are also ways that Maven can show you the dependencies for your project. For example, using the Maven dependency tree, which will print this on the command line. So this is the same hierarchy, but obviously if you have a huge project, it's going to be hard to find where dependencies are coming from. You can of course grab them in the command line, but I really rather like having the window in the project tool window where I can just look for them and expand and collapse as needed, which I can't do with the tree in the command line.
Anyone here using the Java module system or working with Java modules? You know that sometimes it's difficult to find what is the name or for the particular module. Well, Maven can tell you that there is another command that we can invoke in the dependency plugin, which is, I think, is result.
Yes. So let's run that. And now we can see where, what modules they're coming from as well. So same information, but a little bit more details. We can check for dependency updates as well, to see if there are new versions available. This doesn't always, so in this case, it does tell us that this is an alpha, but it doesn't always. So there might be release candidate versions in there as well, but you can't tell on the command line. So always make sure that these are versions that you actually want to use. And then we can also check for plugin updates. So for our Maven plugins.
This will be a much larger list because it depends on the particular version of Maven that you have. There's a section in the XML that you can say what is the required Maven version, not the one that we use with Enforcer. And this particular plugin will latch on that one and figure out what will be the next set of dependencies. But if you're using the wrapper, then again, you fix Maven to a given or hopefully a higher version of Maven so that the set of plugins that you get here as a result will be much shorter and much more exact to your needs.
Yeah, and if you don't define which Maven version, it will give you all of the updates for each Maven version. You can also show unused dependencies, but we don't have the... Is that this one, the analyze?
Yes. For this, you have to have bytecode already. There are two goals that you can invoke, analyze and analyze only. The analyze goal will compile and package your code every single time, whereas the analyze only will expect you to have the bytecode built somewhere else. So you could break down into different compilation sessions as needed. So that's why there are two different commands. So if we invoke it in this case, we did compile already, did we? Or we can try it again.
Let's see. If we run it now without compiling, we have a build failure because we need to compile first.
Yep.
So if we compile first and then run it.
Yeah, we still get the failures because what is happening in this particular project is that we configure SLF4J simple, which is an implementation of SLF4J API. That is with direct dependency. And in the code, we make use of the SLF4J API classes. Simple should be runtime. And we also define explicit in the POM file a dependency to commons lang, which we are not making use of. So what we see in this error is telling us that, hey, you're consuming APIs for something that is a transitive, should make it a direct and explicit dependency in your POM file. And you have an explicit dependency that you are not consuming anywhere in your bytecode, so it might be a good idea to remove it.
Right. And then we might also have dependency conflicts in our project. Wrong place. So let's switch to that demo.
Because everybody loves to have class path dependency hell with Maven, right?
Not really, no. No. So how do we fix that? So let's take a look. Let's open that demo. So again, we can do the Maven dependency tree to see what dependencies we have. And, you know, if it's a short project, then we might be able to figure out whether we have conflicts here. If it's a huge project, maybe not. So then we can actually use the dependency analyzer for the right project, Marit.
Yep, that one.
So then we can see what dependencies have been resolved for this project, and we see the exclamation mark, which should be a hint already. But we can check this button also to show conflicts only, and then we can see which conflicts we have in our project and where they're coming from.
Because as it happens, we only have two dependencies in this project, use and truth. Both of them happen to have a transitive dependency on Guava, which also have dependencies on error-prone annotations and checker qual and a few other things. So just by looking at those two explicit dependencies in our POM file, there's no clue that there is an issue. So the Maven dependency analyzer from IntelliJ can give us directly when you run it. Or if you configure the enforcer, you can also bubble these things to the surface and transform this problem into an actual build error.
Right. So to do that, we have this POM which is enforced. So if we run that, Let me find the command to run. This will tell us what the problem is.
Again, this is the same problem as we had before, but the only thing that we have is the enforcer with some rules configure and enable. And how to fix this? Well, the rules will tell us, well, there are some versions that are kind of duplicated or redundant or do not match based on the rules. So you could use explicit exclusions, which should be your last resort. You could use the Maven dependency management block, or you can use direct dependencies. Depending on your use case, or you're building a library or an application, you will want to use one or the other. And what we have in this particular example, we already have a set of explicit dependencies plus Maven dependency management to fix this issue.
Right. So now if we run it again, it should no longer throw an error. And now we have build success. So obviously how you want to resolve your conflicts might depend. There are different ways, like Andres explained. Yeah. And what's the difference between these two?
The difference between these two, because they actually do the same thing, but one is invoking a lifecycle phase, the initialize, because that's where we bound the enforcer goal of the enforcer plugin. And the other, we are invoking an explicit goal of the enforcer that has the ID. So depending on how you have configured your POM file, you can have everything just let go whenever it's bound to a lifecycle phase, or do an explicit invocation.
Okay. And then we've seen that we sometimes have to deal with vulnerabilities. So we've shown you all of these things and conflicts. But we do have to sometimes deal with vulnerable dependencies. We hope we have tools that will scan for vulnerabilities, and we might need to remediate them by upgrading our dependencies if a new version is available and we can actually use that. IntelliJ IDEA can help you with this. So if we again go to the right demo, let me close these and open these. So for one, if you have vulnerable dependencies in your projects, IntelliJ will highlight them for you. And if you hover over them, you will see the information about the vulnerabilities. And of course, Alt-Enter is your friend, so you can update to an unaffected version if one is available. You can also see the problems in the problem tool window. If you go to the vulnerable dependencies tab, you can show the results, and that will show you all of the vulnerable dependencies in your project with the severity and what's in there. And that will also show you the information, but in your IDE. You can click the link in the tooltip, but you can also see the information in your IDE. But you might want to know whether you're actually using the vulnerable part of a dependency, because if you're not, then it might not be exploitable in your application, so you might not need to upgrade. And we actually have an inspection for that, so we can run inspection by name and look for vulnerable API usage, not for JavaScript, but for Java. Hang on, I want to run that on this specific project. So I want to run it on this module, and that should give me results, but anyway.
Or we can just browse to the source code, and there we go.
So there we go. So if you're using the vulnerable API in your source code, then it will also be highlighted by IntelliJ IDEA and show the vulnerabilities, the same as in the POM file. And here, if you Alt-Enter, it will go to the file with the declared dependency, and then we can upgrade it there. In this case, there is still a transitive dependency in this dependency. So unfortunately, still vulnerable even with the updated version. But yeah, so that might help you deal with vulnerabilities in the IDE. So to summarize, the tools can help you be more productive, both Maven and IntelliJ IDEA.
If something were to go wrong in the build, try it first with Maven without the IDE, because it may be the case there is a missing integration point within Maven and the IDE. If it works in the command line tool, then there's some misconfiguration in the IDE, perhaps. If it doesn't work on the command line, then something is broken in Maven.
Yes, so isolate your problem. And of course, if you find anything that doesn't work, let us know. The same for Maven. If you find stuff that doesn't work with Maven, try Maven 4 and let them know how that works for you. Also, so you can find out whether your projects will work with Maven 4.
Which is hopefully out very soon.
Any day now. So obviously, please rate this talk in the app if you like this talk. You can go to the QR code or go to the mobile app for Devoxx. As promised, if you want the slides, you can follow this QR code, which will take you to my website, which has the slides for this presentation. We'll put the recording on there as well when it comes out, and links to other relevant information.
And with that, we thank you very much for your time and your attention. We hope that you're taking home a few new things that you learned today. Learn more things as the rest of the day occurs. Keep enjoying Box Day Zurich.
Thank you.